Hello everyone, I'm Shiyu. I'm very glad to be here to introduce Milvusdm, which is a data migration tool for Milvus. First, let me introduce myself. I'm Shiyu Chen, a data engineer at Milvus. I have been focusing on data processing, building AI models, and others. This session includes four parts. The first is an introduction to Milvus and why we need a data migration tool. The second part is the introduction to Milvus field structure and the main functions of Milvusdm. Then I will show you how to use Milvusdm, and finally, we will run the code as a practice. Okay, let's head to the Milvus Big Picture. Both the top input and the bottom output are unstructured data. AI technology mainly functions in the middle two layers. The green layer, model inference, and the blue layer, data service. The task of model inference is to transform unstructured data into feature vectors. Models are pre-trained, but serving them efficiently is still not easy. The good news is that there are already some matching projects in the industry, such as NVIDIA TensorRT, Microsoft ONX. Google is also developing TensorFlow runtime. At the data service layer, the Milvus open source vector similarity search engine works. It contains four parts. The first part is the embedding similarity search, which include high dimension dense vector in deep learning scenarios and spread vectors in traditional machine learning scenarios. The second part is the attribute or the scalar data. For example, a label described by structured data like strings. Combine attribute and vectors, we can provide the capacity of hybrid search or collaborative search. The second part is to support multi-models. In the real world, the multi-model search is common requirement. Then we need to introduce the concept of an entity for the unstructured data. An entity can contain multi-vectors of different dimensions. The first part is the scoring component. In some scenarios like multi-model search, because we introduced different models, then the fully connect layers of different models need to be focusing to form a new scoring mechanism for the analyze for unstructured data. At present, Milvus already has built up the vector analyze capacity, and we are constantly improve and enhancing it. We are currently developing the function of attribute filtering. We are planning to functions of model and scoring. Eventually, Milvus is not just positive to be a high-performance vector search engine. We want to be a comprehensive structured software for unstructured data service based on Milvus. We have released Milvus v 1.0.0. It brings many features. It supports for Milvusdm similarity metrics include distance in the product, mean distance, and Jakarta. And Milvus integrate with improvements to ANS algorithms, including Faiss, HNSW, Annoy, and more. Milvus can also use mishaps to sharding the proxy. It also supports the processing commonly used AI scenarios include Chabaloo, NVIDIA GPU, and more. Milvus is an ongoing open source software project. Still, we believe the first major release is important to our community users. Actually, Milvus version 1 will be supported for a long term. It can be ready integrated into the AI ecosystem, and it's now well structured to move the next stage. Yeah, we are going to build a community driving open source AI project, and there is three types of community organizations, including special interest group, a working group, and the technology steaming community. And the Milvusdm is a project of the SIG, and we are warmly welcome you to join our community. For example, you can join us as a participant, a contributor, a viewer, and a committer. In short, you will be a part of community by share and discuss your ideas to the open source. Then let's take a look at Milvus data migration tool. So why do we need a Milvus data migration tool? For example, you are supposed to transform data to another system, or you need to backup data or system upgrade without a right tool. There is a cycle of exporting, transform files, creating tables, importing, and data validating. So that make the data management very cumbersome, but a good data migration tool can greatly improve efficiency of data migration and reduce the DevOps cost. So what features does Milvus data migration tool support? It supports to transform such as import and export data, as well as data backup and data restore, and the system upgrade. Before introduce Milvusdm, let's take a look at Milvus data file structure. For example, if I create a collection and name the example collection and create a partition and the collection named test, the file structure and Milvus DB will look like this. You can see the partition and the collection are in the same directory, and in fact, each partition is a collection. The relationship between partitions and collections can be determined from the owner table and the partition tag field in the metadata table. It can also get the segment information for each collection. For migration data, we are interested in the three main files. The file with the RV suffix, which is the original vector file for each segment. The file with the UID suffix, which is the ID files for each segment, and the delete docs, which is specific the offset of vectors to be deleted. With those three files, we know how to read the vectors and the corresponding IDs in Milvus. So how do we read these three files? Let's take the Python code as an example. We know that the files is saved in bytes format, with the first 8 bytes saved the size of the data. For example, if we have 10 vectors of 100 dimensions, the first 8 bytes of the RV file will be 4,000, which means the size of the vector is 4,000 bytes. The next 4,000 bytes are 10 items of 100 dimension floating data. The way to read the vectors is use the from file API in NumPy and specify the data type as float 32. And finally, reshape the vector as a two-dimension based on its number and dimensions. The IDs corresponding to the 10 vectors are stored in UID file. The data type of the ID is int 64. So the size of the ID is 80 bytes. What is stored in the delete docs is the offset of the vector being deleted in the segment. For example, if we deleted 3 vectors, then the first 8 bytes are 12, and the next 12 bytes are the offset data. The Python code is shown in here. Milvusdm search for features Faiss to Milvus. It supports to import the data of Faiss index file to Milvus in a specific collection or partition. HDF to Milvus can export the data of one or more HDF file for format files to Milvus in a specific collection or partition. Milvus to Milvus. It can copy a collection of source Milvus or multiple partition in a collection to the desk Milvus. Milvus to HDF file. Export the data of a collection or multiple partitions in a collection of Milvus to the local HDF file format file. In addition to the above 4 functions, if you have any other requirements, please feel free to submit an issue to us. There is the GitHub address. So how does Milvusdm work? First, we configure the YAML file according to your own environment, and then run Milvusdm to do the specific task. For example, if we want to import Faiss data into Milvus, we would first call readFaissData class, which will read the vector and ID data from the Faiss file, and then call data to Milvus to import the data to Milvus. In case of HDF file to Milvus, call the read data class first to read the vector and the IDs data, and then call data to Milvus to import the data into Milvus. If you want to migrate data, Milvus data to another Milvus, call the read Milvus data class. Read the previously mentioned 3 data files from Milvus and return the vectors and IDs, then call the data to Milvus to import the data into Milvus. In case of Milvus to HDF file, the read Milvus data class will be called first and return the vectors and IDs. Then save data will be called to save the data to a local HDF file format file. Next, we will learn how to use Milvus. focusing on the configuration fields for each feature. For example, if we need to migrate data from Faiss to Milvus, we first download the configuration file using the wget command and then set the parameters. Data2path means the path to the data in Faiss. Desk host and the desk port is your Milvus server address and the port. Mode is the mode of importing data of Milvus. You can select from skip, append, and overwrite. Skip means ignore if the collection or partition already exists. Append means append data if the collection or partition already exists. Overwrite means if the collection and the partition already exists, delete the data before inserting it. And the dest collection name and dest partition name is the name of the collection or partition to import data. Collection parameters is the collection specific information such as vector dimensions, index field size, and the distance metric type. All these parameters need to be modified according to your own environment. Once the parameters have been set, you can run Milvusdm --yaml f2m.yaml. When we need to import data in HDF5 format into Milvus, as usual, you first download h2m.yaml using wget command and then set the parameters. Unlike f2m, here the data path refers to the path of the HDF5 format file. It supports more than one path, and the data dir can specify the directory when all the files to be imported. Only one of those two parameters should be set. The other parameters are the same as the f2m. Once the parameter have been set, you can run this command. At this point, you are thinking, what should I do if the data format is not HDF5? If you need to import data in another format, please submit an issue to us, or you can contribute code. We'll also introduce the code structure and how to contribute later. The next is to migrate data from the source Milvus to the target Milvus, which need to download and set the parameters. The difference of the previous is the additional MySQL and the source parameter. Where source Milvus path is the working path of Milvus. MySQL parameters is the name of the collection. Is the parameters of Milvus as metadata management in Milvus. And the source collection parameters is the name of the collection to be exported, where only one collection can be specific and but multiple partitions. Once you have set the parameters, you can run Milvusdm YAML Milvus to Milvusdm this command. Currently, M2M only supports data migration from Milvus 0.10 and Milvus 1.0. In the future, we plan to able to migrate data across mirrors. The last function is to export data from Milvus and store it locally as a file in HDF5 file format. The data dir indicates the directory where the data is stored. In summary, Milvus accomplish the above four features, all of which are simple. So let's take a look at the code structure. The file modeling contains the core directory as well as the generic function for each feature. Milvus data to Milvus can create a collection or partition and import the data to Milvus. Milvus client is a function about Milvus, such as insert data and create a collection. Read data can read local data files in HDF5 files in the local drive. You can adjust your code here to support reading data files in other formats. Read Faiss data can read the data file in Faiss. And read Milvus data can read Milvus data file. The Milvus meta is to get Milvus the meta info. Save data can save the data as a file in HDF5 format. And write logs can write debug info error logs. Faiss to Milvus is a function to import Faiss data into Milvus. HDF5 to Milvus is import local HDF5 file to Milvus. And another two main function. Main PY is read the YAML file and execute. Setting is including the configuration parameters. Setup is used to load the code to the PyPI is Python package index. The code structure is introduced to be better understand of Milvusdm. So you can read the source code if you are interested in the project. Let's take a look at the to-do list, such as Faiss to Milvus. We are planning to support binary data. As for Milvus to Milvus, except the addition of block list and allow list, but also planning features for data backup and recovery. If you have any ideas, we would be happy to discuss these features. Milvusdm can be found at this link or by searching Milvus tool on GitHub. To contribute code, you can first raise an issue to the project, then we will discuss at it. And finally, submit a PR to become a contributor. Then you can proudly say that I am a contributor of Milvus Untitled Chapter. Next, let's run Milvusdm. Before running it, I start to Milvus on my machine. One version is Milvus 0.10.4, and the other is Milvus version 1.0.0. And I also start Milvusdm as a front-end interface. Then let's take a look at Milvusdm in browser. we can see that the port 19121 is connected to Milvus version 0.10.4, and it has text collections in 10 pieces of data. And the port of 19122 is connected to Milvus version 1.0.0, and there has no data. So if you want to migrate the text collection from Milvus version 0.10.4 to Milvus 1.0, then we need to download the M2M YAML and set the parameters. First, we download it. Then we can set the parameters. First, we need to modify the source Milvus path according to my own environment. Then, because the Milvus doesn't use MySQL as metadata management, so the parameter is set to empty. Then we want to migrate text collection without partition, so the partition will be deleted. Next, we will change the dest port. The mode we choose append. Then we can write. So we can see that we transform the Milvus data successfully. Okay, we see that there is 10 pieces of data in the text collection of Milvus version 1.0, which was migrated from the source Milvus. If we run the command again, yeah, we can see the data will be appended to the Milvus, and the count become 20. Isn't it very easy to migrate data in Milvus? Come and try it now. Thank you very much, and I hope you enjoyed today's talk. Next is our Q&A session. We will talk any question on here. If you want to know more about Milvus and how it can solve your search problem, you are also welcome to visit our website, follow our Twitter, or join our Slack channel.